Good afternoon, students. Today in this class, we are going to discuss a case on wind power plant, which is an electrical fault occurred in a wind power plant, and what are the causes and what are the reasons and how we can rectify in this future. Uh, so we are going to discuss this in this case study. Okay, shall we discuss? Okay, so can anyone say what fault happens and introduction about this fault?
So we are going to see about the fire incident in nacelle due to electrical fault in power plant. So the introduction I'm going to give about is wind power plants are highly dependent on electrical and electronic systems that operate under high mechanical, thermal, and environmental stresses. So one of the most critical safety challenge in wind turbine is nacelle fire incident. The most commonly triggered by electrical faults, overheating components, or insulation failures. So this case study we are going to see is examines an actual scenario based incident and analyzes causes, effects, and preventive measures.
Okay, so what are the main background of this wind power plant?
So the rated capacity of the wind turbine is around 1.5 megawatts. The hub height is around 80 meters, and the location where the power plant is coastal wind farm, and the environmental conditions are of high humidity and salt laden air. So the age of this turbine is about 8 years. So this turbine has a history of intermittent temperature alarms in its control panel, but no critical shutdowns before the incident.
Can anyone explain the descriptions of this incident?
So this incident has happened on 14 July 2024 during peak afternoon winds. When the wind speed is 13 to 15 milliseconds. The SCADA system detected a rapid increase in nacelle temperature. Within minutes, smoke was observed coming from the top of the turbine. So the sequence of the events are sudden temperature spike in control panel compartment. SCADA issued warnings, but not an immediate trip. The next one is operator tried remote shutdown. Internal wiring insulation caught fire. Fire spread to capacitor, back and converter modules. Fire suppression system did not active. Nacelle was completely burnt within 20 minutes. No personnel were injured, by turbine suffered the major asset loss.
Okay, so what are the physical observation of this?
So the physical
After the fire.
observations after the fire are several burn marks around the capacitor bank, then melted high voltage cable insulation, then charged control panel components, smoke residue inside nacelle housing, fire suppression bottle intact, through sensor for failure confirmed, ventilation ducts clogged with dust. So these are the physical observations.
Okay, so can anyone say what are the root cause analysis for this incident?
So I'm going to say about root cause analysis. The primary cause electrical arcing in the main power cable due to insulation failure and high humidity plus dust plus arcing insulation and caused a short circuit that resulted in the arc flash.
Okay, what can you explain the contribution work?
So contribution factors are aged capacitor bank, dust and humidity accumulation, overloading during peak wind, and fire suppression system malfunction, and inaccurate and monitoring. First one I'm going to say about age capacitor bank. Age capacitor bank is the high internal heating and poor maintenance records, and dust and humidity accumulation. It's due to increased the rate of inflation degradation and increased partial discharge activity. And next, I'm going to say about overloading during peak wind. So overloading occurs due to high current flow, cost additional and heat stress. And next I am going to say about the fire suppression system malfunction. So fire suppression system malfunction occurs due to sensors not calibrated and the fire spreader uncontrolled with no response. And next I am going to say about the inaccurate temperature when monitoring is due to no early warning and terminal or IoT based temperatures.
Okay. Can anyone say what is the impact of this incident?
Now I am tell about the impact of the incident. The completed nacelle destruction in a 3-month downtime. The replacement cost approximately the 1.2 crore. The loss of 2.8 gigawatts of annual generation. The insurance of the evaluation to and the investigation is delays. Safety reviews in the entire form.
Okay. So what is that? Can anyone say faulty analysis? Faulty analysis.
Fault tree summarizes top even nacelles fire in the electrical fault. There have the cable insulation and a breakdown, and a capacitor breakdown overheating, and loose electrical connections. And another one is suspension of the failure, sensor and malfunctioning, and the periodic testing. And the third one is the environmental fact. Environmental fact, there have the dust accumulation and high moisture content.
Okay. Faulty analysis. What is it? Can anyone say the corrective actions? Corrective actions.
So I'm going to explain about the corrective actions in the nacelle failure. The complete rewriting and replacement of burned electrical modules, and the second one is installation of advanced arc flash detection sensors, and the replacement of suppression system plus monthly timing, and development of thermal monitoring like sensors like IoT plus IR cameras, and the fourth one is enhanced nacelle ventilation and dust filters. And the fifth one is technical training or insulation inspection and capacitor health. And final is SCADA threshold settings adjust for area shutdown.
Okay. Can anyone say the primitive measures for future incidents like this?
The preventive measures are scheduled infrared inspection every 60 days, and second one is conduct condition-based monitoring using vibration plus thermal analysis, and high quality insulation material rated for coastal conditions, real-time capacitor health analytics, automatic shutdown for abnormal rises like 10 degree greater than 10 degrees Celsius per minute, grounding systems reinforcement, and the final is annual electrical audits.
Okay. Can anyone say conclude this case study?
I'm here to conclude the case study. This case study highlights the electrical fault and remains the one of the leading causes of the nacelle fire in the wind turbine. And then the combination of the again components, environmental and stressor and the indicators suspension system can lead to the counter failure. And a protective maintenance, they have a modern monitoring system and a robotic fire alert detection are essentially to prevent the similar induction of the monitoring the wind turbine. Thank you.
Okay. Okay, thank you, students. Today we are discussed about wind power plant electrical fault analysis, and we'll meet in next case study class. Thank you.
Thank you, ma'am.
Thank you.